There are some trigonometric angles that get special attention, and let's look at those triangles. The first is half of a square, and this one would cut like a sandwich. You can eat that, right? That one. So this trigonometric shape, in a square this angle is 90 degrees, so this is 45 degrees, and because this side, the two sides are the same, I'm just going to call them 1. This is also 45 degrees, of course, and this is of course square root of 1 square plus 1 square, so root of 2. So this triangle, this 45 degree triangle, you can just draw in a corner like this and call it 1 1 root 2. So this is one triangle that will get used, in which this is 45 degrees. So that gives you, for example, sine of 45 degrees is 1 divided by root 2. Cos of 45 degrees 1 divided by root 2. Tan of 45 degrees is 1 by 1, 1. So you can see that very easily from this. And if you are given problems to solve in which, let's say this is 100 meters and this is 45, this is 100 root 2. You just have to multiply it by root 2. If they ask you the length of the thread for a balloon that's in the air for 100 meters, and that's what it means. You can use this triangle very quickly for this kind of a problem. Then the other special triangle is half of an equilateral triangle. Okay, it's supposed to be an equilateral triangle. Yeah, more or less. Okay. And so when I cut that in half, and let's say I call half that side 1, then this becomes 1 and 2, and this one becomes square root of 2 square 4 minus 1, which is root 3. So this triangle, conveniently, this triangle is 1 1 root 2 triangle. Remember this triangle 1 1, so this is 100 meters by the way. 1 1 root 2 triangle, and this triangle, which has, this is obviously bigger, so this is 60 degrees, and we know that in an equilateral triangle this was 60 degrees. This is what is left, so that's 30 degrees. So this triangle I like to call as, it should be half of that. Okay, yeah. 1 2 root 3, where this is 60 degrees and this is 30 degrees. Okay. The 30 degrees will see a smaller side, the 60 degrees will see a larger side, which is that. So again you can do root 3 by 2, you can see the sine of 60 is root 3 by 2. Interestingly, that will be the same as cos of 30 degrees because they are complements of each other. So this one sees this as the opposite side, this one will see this as its coside. Yeah, that's the side that's next to it. Okay, and so what is, so I think these are the two triangles that are coming, and now even most textbooks are now noticing it clearly that these are the two set squares. No? These are the set squares that are there in your geometry box, and certainly you can see the 45 degree one has both sides the same, so at least the 1 1 part is obvious. 1 1 and root 2 is this basic Pythagoras theorem, you should practice that. And 1 2 root 3, you remember these two, you should be able to do quite a few of the questions based on this.